Problem 51, Chapter 17, Giancoli 6th edition. So what we have here is they want to know how the energy that is stored in the capacitor changes in certain two different scenarios. In the first case, what we are going to do is we are going to double the potential difference. So instead of V, now I will have twice as much potential difference. Okay, and we want to know what is going to happen to the potential energy in this case. And then question B is the charge on each plate is double. So instead of Q, my original Q, I'll have 2Q. Okay? To solve these problems, we will need to use the equation for potential energy. We know that potential energy is equal to QV divided by 2. This is one way to write the equation. We also know that potential difference is, if I use here that Q is CV, I can rewrite this equation as CV squared over 2. And finally, I also know that I can write it as, if I, instead of V, I put Q divided by C, I have Q squared over 2C. Okay, so all of these equations are equivalent. They are just written in terms of two different quantities, Q and V, C and V, or Q and C. All right, now to answer these two questions, the best thing to do is to select the equation where just one of the quantities change and the other one is fixed, the other one is constant. Okay, any of these equations can be used to answer this question, but the best one, the one that will give us the least chance of making a mistake, is to choose the one for which only one quantity changes while the other is fixed. Okay, so let's start from part A. Part A is the potential difference is double. The potential difference is double and the capacitance is constant. Okay, I'm not touching my capacitor, I'm not bringing any dielectric. My capacitor is constant. The only thing that I'm doing is I'm changing the potential difference. How can I change that? Well, I remove the battery that I have and bring another one, a more stronger battery, for example. Okay, so that's what I did. I didn't do anything to my capacitor. I just discarded the battery that I had there and brought another one that is twice as powerful. Okay, so all this to say that in this part A here, what I have is the capacitance is constant. And what I change is the potential difference. So what is the best equation to use in this case? Well, the best equation to use is this one. This one here. I have C is constant, and just the potential difference is the one that changes. Okay, so if I use this equation, this is my best choice here, is CV squared divided by 2. C is constant, V is twice as big now, 2 squared gives me multiplied now by 4. Multiplied by 4, right? All right, so the next question is, Q is doubled, and Q is doubled while the capacitor remains connected to the battery. So what they are telling us here is that potential difference is constant, potential difference is not changed. I have still the same battery. All that I'm doing is I'm increasing the charge. How can I do that? Well, for sure, we brought there a dielectric. And that's the only way for this capacitor to receive more charge. Okay, so that's what we did. Q increased, potential difference is constant. What is the best equation for me to use among those three? This one. So I don't need to think much. Since V is constant, I just need to take into account that Q is now twice as large. So this is the equation I'm going to use to answer this question. QV divided by 2. Since Q now is twice as large, I know that my potential difference will become twice as large. No? So my potential difference will be multiplied by